So just for notation purposes, we define a function for the result, which is our partial sum, and another function for the carry. So each function takes two inputs, and it generates one output. It's just notation at this point. Do we have any questions about this? Now there's also another alternative. Yep, go ahead.
The XY with the position, what would that be? Would that be X and not Y, or?
Correct. Yeah, it is X and not Y because the prime is the negation.
Is it the same thing as not X and Y?
This part here is X, and then this part here is not Y.
Oh, okay.
So this entire term is X and not Y. This is X prime, which is not X, and this is Y. Because they are multiplied, it becomes not X and Y. And then
So
this
not
term.
goes on the letter.
Correct. Now there's yet another notation. Let me see if I have that in my notes. I think I do have that in my notes too. There's yet another notation which is to use a bar on top of the letter to mean negation. And I think I have, oh, I do have that. Nope, not that.
If we're used to that, can we use that?
Sorry?
If we're used to that, can we use that? Used to the bar on top.
Yeah. Yeah, I'm looking for my notes that uses a bar on top to represent it.
That and the L-shaped thing in front of it.
Not the L-shaped thing, it's a bar.
Yeah, I know.
Let me see.
For
Okay, if I don't have it, that's okay. I'm going to use a word processor to express it. Okay, so turn on writer. This is my de facto, whiteboard, because I don't want to use, the actual whiteboard where it's not screen captured. So when I do everything on the computer, then it will be screen captured, so that you guys don't have to busy, copying everything down, and you can just focus on the concept instead. All right, so here we'll do everything here. So we have the original expression is X and not Y, or not X and Y. Okay, but you can also make this for electrical and computer engineering. This is also known as just XY plus XY, but you have to make sure that you have the bar correctly. So here, because we are negating the Y, we need an over bar for the Y. So we have to go to here, character, font effects, overlining, single, okay. And then here, we are negating the X, so we'll put a bar on top of X. So we go to do the same thing, format, character, overline, like so. And kind of make it bigger, big, like that. So for electrical engineers, the second line is the notation that you will be encountering the most frequently, because it is a lot quicker to understand. It's very short and it's very concise. Because a bar on top of something means the negation of that something. Is that okay so far? It's just notation. I'm not going to quiz you on these things. I just want to let you know. So next time you see something that looks like this, you know what it means. Yep.
I understand all the concepts we've been going over, but I don't understand what a half adder actually is.
A half adder is, well, you can call it a half-ass adder, okay? Because it's just doing adding half-ass. Okay? You need two half adder to become a full adder to really finish the job. Okay, so that's a good question. Why do we have half adders, and why is it not finishing the whole job? All right, that's a very good question. Okay, so we'll switch back to the mousepad, which is my text editor here, and we'll go through an example. Okay, this is an addition example. So we got 0, 1, 0, 1 plus 0, 1, 0, 0, 1, 1. Okay, and I'm going to use exactly the same format as I usually use in this class. We have an implicit 0 here because there are no less significant digits to contribute a carry to this particular column. Okay. What do we put here?
0, 0, 0.
1 plus 1 is a 0. That's my partial sum, right? Guess what? I have just used up one half adder. Right? Because every time we say 1 plus 1 is 0 with a carry or something like that, we are only dealing with a half adder. We are only finishing half of the calculation for one column in this particular addition. Okay? So we'll go through this whole example. Okay? This is 0, and it is already generating a carry to the next digit. Okay? Are we done with this column?
No.
Do we have a final result for this column?
No.
Not yet, right? So now we have to ask another question. What is 0 plus 0? 0 plus 0 is a 0 with no carry. That's the second application of a half adder. Okay? So that means in order to finish the calculation of one column, one bit, we need two half adders. And that's why it has a name of half adder, because each one is only finishing half of the job of adding for one single bit. Is that okay? But that was a really good question. I really like that question. Because understanding why the name is that name is very important, because it kind of helps you to fit everything in the picture. Okay. So if you want to, we can just finish this too as another example, another exercise. 0 plus 1 is a 1 with no carry. That's using one half adder. 1 plus 1 is a 0 with a carry, is using up another half adder. So up to this point, I have used 4 half adders already. 1 plus 0 is a 1 with no carry. That's another half adder here. 1 plus 1 is a 0 with a carry. That's another half adder. 0 plus 0 is a 0 with no carry. 0 plus 1, that's one half adder. 0 plus 1 is 1 with no carry. So the final carry is basically a 0 because there's no carry out of the entire 4-bit addition. But throughout this entire process, how many half adders have I used? We have used up 8. Okay, very good. So getting back to the notes. Where am I? Half adder right there. So here we have, we are relating what a half adder is, and how do we come up with a full adder? So let me make this a little bigger. Here we go. Okay, so the notation is a little bit different in this case. Let x subscript I, let me bump up the font size here. Let x subscript I represents the value of bit I of a number x and y. Okay, so x is a multi-bit number, and y is also a multi-bit number. X subscript I refers to bit I of x. Does everybody understand that notation? It's kind of like a square bracket in array, indexing. Okay. If we want to calculate the sum of x and y, then I'm going to use this notation as subscript I to represent bit I of the sum itself. Okay. The carry bit from the addition of bit position I is represented as carry, C subscript I. Is that okay? Using the result and carry functions R and C, well, this part here is really a math notation for all I in from 1 to n minus 1 inclusively. The sum is going to be the result, or the partial sum, of the partial sum of that particular bit, and also the carry bit from the column to its right. Okay, again, I think it's probably better to use an illustration. All right, illustration. Yeah. All right, so here's the illustration. We have x as a number. So x, let's say x is, to make it simple, let's make x and y 2-bit numbers. So we have x1 being 1 bit of x. We have x0 being 1 bit of x. We have y1 being 1 bit of y, y0 being another bit of y. And we always start with the least significant digit. It's called bit 0, not bit 1. We count from 0. We count from 0 because it is representing 2 to the power of 0. All right, so just to apply what we have learned earlier, what should I put here? Well, no, it's not always 0. It is the result or the partial sum of x0, y0, right? The R function generates the partial sum. Okay. And what do we put over here?
C.
Now this one is just 0 because it has no less significant digit to the right hand side. So that's just a 0. Which means in the final result here, this is really just Rx0, Y0 because it's simply because of this thing here is always a 0. What do we put here?
Rx1, Y1.
Exactly. So we have R, oops, I need to turn on insert mode, R, X1, Y1. So now I have to realign everything. Really should have used a spreadsheet. And for people who took a cisp310 from me, you know how much I can abuse a spreadsheet, right? All right. Question here. What do we put here?
That's a C. C0, X0, Y0.
This is an easy one because it's just the carry of x0 plus y0, so it's just C x0, y0. Okay, so it's C x0, y0. This is a really easy case because we have a 0 here. Okay, that's the only reason why it's simple. And then what do we put here?
That's the R parenthesis R parenthesis X1 Y1.
Exactly.
Comma C X0 Y0.
Yep. So it's the R of. Yes, I'm lazy. And that's why you should not be copying this. Okay, now we have to realign everything. Really should have used a spreadsheet. Too much space in between. Don't. Yeah, kind of picky about this. All right, there we go. Is that making any sense? Is that all right? What if I have, x2, y2? Let's do that, okay? Because, this does not really represent, what I wanted talk about because we haven't seen the case where the C includes a big mess inside of it. So what we want to do is to put x2, y2 here. This is the easy part, isn't it?
Yes.
What should go there?
Rx2, Y2.
Yep. The partial sum of x2, y2 goes here. Okay, that's a really kind of easy one. And let me realign everything. Trust me, the realignment is not quite done yet. Okay, it's going to get a little bit more messy than this.